As mentioned previously, the dermis is primarily connective tissue, but it does contain other tissues like nervous tissue for the neurons. Um, there's also some muscle in the dermis. But we're going to, again, use this summary table and describe the different regions of the dermis and compare this information to this drawing on the right. So if we move through the epidermis into the dermis, the more superficial region just underneath the epidermis is known as the papillary region. The papillary region is largely made up of areolar connective tissue. So if you recall, areolar connective tissue is kind of a mix of different fibers, collagen, elastic fibers primarily. There's some cells in there called fibroblasts, and these fibroblasts are producing the fibers. And there are some nerve endings that extend up into this papillary region. There's a specialized one called Meissner corpuscles of touch. There are also some other what we call free nerve endings. Those would be like pain neurons, for instance. So if we look over here at the drawing, we see that the papillary region is here, just beneath the epidermis. It got its name from these dermal papillae. These dermal papillae are these kind of pointy extensions that stick up from the dermis. And what they do is they kind of lock in to the epidermal ridges. And that provides a nice, strong connection between the epidermis and the dermis. If we go deep from the papillary region, which is the thinner region of the dermis, we would then go into the thicker region, which is known as the reticular region. The reticular region of the dermis is not reticular connective tissue, so try not to let that confuse you. The word reticular just means branching, but it's not reticular fibers. It is actually collagen fibers that give it its reticular or branched look. The actual tissue that makes up that reticular region is dense irregular connective tissue. So recall that dense irregular connective tissue is made up of a lot of thick bundles of collagen that kind of run in all kinds of different directions. And what that allows the skin to do is move in different directions without tearing. So it gives it a lot of strength, but strength in all directions. There's a lot of fibroblasts found in the reticular region. There tends to be more of different things like adipocytes. There might be some adipose cells. There's much more of the hair follicles found deeper in the reticular region. There's a lot of the glandular portion of sweat glands down in these regions. So you'll notice these are sweat glands, and the structural component that produces the sweat is deep down in the reticular region. The sweat ducts then will extend up through the papillary region, through the epidermis, in order to deliver that sweat through a pore onto the surface of the skin. Some sweat glands, as we're going to mention in a minute, will send their sweat into the hair follicle, and the sweat kind of goes up with the hair. So you'll find sweat glands, you find a lot of nerves. More nerves are found deeper you go. That's why the deeper the injury, the more painful it might be. You'll find some sebaceous glands, which are attached to the hair follicles. This is a sebaceous gland right here, which we'll learn about later. Those are the oil-producing glands. And then sudoriferous are the sweat glands. So we'll talk more about glands as we move forward. But the reticular region, again, is deeper. It consists of about, as it mentions here, 4/5 of the dermis. So most of the dermis is reticular. If we look really deep down, we find another specialized nerve neuron known as the lamellated Pacinian corpuscle. Those are actually pressure sensors. So superficially, you find the Meissner corpuscles of touch. Those are touch sensors that are found up in these superficial areas of the papillary region. And then deeper down you go, you find more of the pressure sensors called lamellated Pacinian corpuscles. You find a lot of those on the bottom of your feet. Your feet are always sensing that pressure, so we know what foot is on the floor and what foot isn't. So you typically find a lot of those pressure sensors on the bottom of your feet. So we see the papillary region, we see the Meissner corpuscles in the papillary region, we see the reticular region and all its goodies, and the Pacinian corpuscles that are found very deep in the reticular region. Sometimes they even sit in this subcutaneous area beneath the skin. Some accessory structures. Hair and hair follicles. Hair serve a number of functions. One function is to help regulate temperature. Hair can actually keep warm air against the skin. So for example, an animal with a lot of hair, like a bear or some other hairy animal, that hair will kind of stand up and it keeps the air warm close to their skin. We lose a lot of heat off of areas of the body that might lack hair. The hair can also be a sensory structure. It helps kind of detect sensory information in the external environment. We have a lot of hair that keeps things out of our eyes. So for example, your eyebrows and eyelashes are used to keep sweat and other debris out of the eyes. But a hair basically has different components. If we look deep down, there's a bulb. So the bulb is the deepest region of the hair. It contains a blood supply in a little notch in the bottom of the hair called the papilla of the hair. That allows blood flow into that hair. Then there would be a hair root, which is also surrounded by the hair follicle. And then the component of the hair that extends out from the skin is called the hair shaft. So you have the hair bulb, the hair root, and then the hair shaft. Surrounding the hair is the hair follicle. The hair follicle is largely epithelial tissue that comes down and surrounds that hair. So it's kind of an extension of the epidermis that surrounds that hair. So another, again, major component is that blood supply. If we sever or maybe laser that blood vessel, that hair won't grow. So this hair grows much like the epidermis, where the cells that are closest to that blood supply will be dividing the quickest. As they get pushed up through the follicle, they begin to die. So by the time the hair reaches this point and extends out from the skin, those cells are completely dead. Hair is made up of dead keratinized epidermal cells or keratinocytes. Nails are very similar in that the nail is made up of completely dead, highly keratinized cells, so it gives it a lot of strength. Nails are used to protect the distal ends of our fingers and toes. This nail will grow down at the nail matrix, and it will be pushed out from that area. Different components of the nail root, the eponychium is this cuticle here, which is kind of a buildup of stratum corneum. There's a lighter component at this back area called the lunula. Then the nail bed is what the nail rests on. And then finally the nail body and the free edge is what you trim or If you have the bad habit of biting your fingernails, that's the end that you bite. Underneath that free edge is the hyponychium. So there's different parts of a nail, different parts of a hair. Obviously, the function isn't vital. You can live without hair. I live without hair on top of my head. You can live without fingernails, but if you've ever lost a fingernail or know someone who has, quite often they damage the end of that finger. So on these diagrams, I've highlighted or put asterisks next to the major things to remember. The next video, we're going to look at how the skin repairs. If your skin is primarily responsible for protecting you, it can often be damaged, and we're going to look at some of the mechanisms by which the skin will repair itself.